Welcome back, ladies and gentlemen, to Physical Science with Mr. Kenton. Glad you can join me today. And today we are going to be starting a new unit focusing in on the structure of the atom. Okay, now to start off, just going to give you guys some information as it pertains to the North Carolina State Standards. This is the state standard. The goal from this PowerPoint and everything that we're going to be looking at moving forward is to be able to interpret data presented in the Bohr model diagrams and dot diagrams for atoms and ions of elements 1 through 18 on the periodic table. Now, if we break that down, what is it that I want you guys to be able to do once we complete this unit? And what that's going to look like is being able to describe the charge, the relative mass, and the location of protons, electrons, and neutrons within an atom. The second thing, I want you guys to be able to calculate and determine the number of protons, neutrons, electrons, and the mass number in neutral atoms and ions. I want you guys to be able to explain how the different mass numbers of isotopes contribute to the average atomic mass for any given element on the periodic table. You guys should be able to use what's called isotopic notation to write chemical symbols for various isotopes. You should be able to explain the Bohr's model of the atom. And by the end of this unit, you should be able to draw Bohr models for elements 1 through 18. Okay, now in order for us to get to that point, we've got to talk about a couple of other things first. So let's go ahead and dive into an introduction on atoms, what they are, and what pieces of information that they tell us. Okay, so matter and the atom. If you think back to previous unit that we just finished up, we talked about matter. And if you recall, matter is any object that has mass and volume. Another way of thinking of that, matter is any object that occupies space and in a sense can be measured to have a weight of some kind, right? Now, when we talk about matter as a whole, all matter is made up of tiny particles called atoms. So anything that we interact with, whether it's a solid, a liquid, or a gas, it's made up of tiny particles called atoms. Okay. Now, this idea was first proposed by a Greek philosopher named Democritus. Okay. Now, Democritus, this was during BC times, so and he believed that there was a particle that made up matter that could no longer be divided into other parts. Now, based on technology restrictions, he had absolutely no way to test and prove this. And so his idea, though it was an interesting proposal, didn't really gain any traction. And so it was actually kind of forgot about for almost 1,500 years before somebody else decided that they would pursue this idea of the atom. Now, much later, you have other scientists. I've listed some of them here. You've got John Dalton, Robert Millikan, J.J. Thomson, Ernest Rutherford, and there are several others who made some pretty important discoveries that have helped us to better understand the atom through experiments that they were able to do, able to determine and identify the presence of a proton, the presence of an electron, the presence of a neutron that make up the atom. Okay, and so that's just a brief introduction to how matter, which we learned about in our previous unit, connects to where we are now. That matter, as we know it, is made up of these tiny particles called atoms, right? Now, let's dive into that a little bit more, right? So what is the atom? How could we define what that is? So if you had to give me a definition, this is what I would say. It's the smallest particle of an element that has the properties of that element as a whole, okay? And so when you think about it, when you break it down and you get it down to this atomic or this very small scale, The atom is this particle of the element that has the same properties of the entire element as a whole. Now, atoms are considered to be the building blocks of matter. And it's important to recognize that atoms are extremely small. They have a radius that is less than 1 nanometer. That's pretty much smaller than if you were to just put a little dot on your paper with a pencil mark. It would be smaller than that, okay? And where we are currently in our understanding of the atom is that it can be split into 3 smaller particles, right? You have protons, which have a positive charge. You have neutrons, which have no charge whatsoever. And you have electrons, which are negatively charged.